Inspiring action. You're tuned into the all-new Action One Network. Turn up your volume.
All right. Hi, everybody. This is another wonderful day. There you go. Or rather, here it's a night. Depending on when you're listening, it might be day or night. Anyways, you're listening to SG2 on Space, episode 21. All right. So, today came in a little bit late, so we got a little bit less time. I figured we'd cover, as always, the great beyond. I have thrown in some special topics in there. Space cowboys, yeehaw, and astrobiology, or really, I just want to talk about weird stuff. So, yeah. All right. First announcement, as you guys know, probably the... oh, yes. First announcement, before we start, hopefully you're listening and following us at facebook.com/action1media, ACTIONONEMEDIA. And of course, you're following this particular show, not just the media station, at facebook.com/The Shen Show, spelled THESHENSHOW. I just found out last night that some of y'all had trouble accessing it, and it turns out I did not turn it for public viewing, which is terrible. So now anybody can view it. Great job, all right? So you don't have to be my friend or already part of Action One Media to actually watch the show. All right. And of course, check out the website for Action One Media at weareA1.com. One spelled with the number one, not the letter. And although people tend to, I don't think people have done this yet, but feel free to support me at patreon.com/SG2. I think I may even put up a store so that motivate you guys to actually support my the show. After all, it's the only weekly space show here in Houston and possibly Texas. Okay, not the United States though. All right. So first off, Mars rover finally dead. All right, that just came out yesterday. Sad, but it's an opportunity Mars rover, right? Originally, it was supposed to last only 6 months, and now it lasted over 8 years, which is incredible. I mean, come on, think about it. You design something for 6 months, and it has a lifetime that's 16 times greater than that. I mean, NASA's Jet Propulsion Laboratory really outdid themselves, I would say. So, Thomas Zurbuchen, Associate Administrator of NASA Science Mission Directorate, basically said that I declare the Opportunity mission as complete, and with it the Mars Exploration Rover mission complete. Hopefully we can get a little video up there of him actually talking and saying that, basically. So while we're doing that, while we're getting the video up, just to provide you a bit of background, Spirit and Opportunity, remember those are twin exact same rovers. They launched separately in the summer of 2003, and they basically kicked off what's collectively known as a Mars Exploration Rover, MER, M-E-R mission, and they landed a few weeks apart in January 2004. Spirit came down first, landing in a crater called Gusev, about 14 degrees south of the Martian equator, And Opportunity landed on the equatorial plane called Meridiani Planum on the other side of the planet from Gusev. So they landed on the opposite sides of the planet. So then they basically went around, okay, where they hunted for signs of past water activity and did science in general. So essentially, they were very successful. They established the presence of liquid water on Mars and confirmed speculations. And it's not just a little bit of water. And it showed in the past there were a whole lot of water. And Opportunity's analysis also showed that this ancient water, which is somewhere between 3.5 billion, 4 billion years ago, had a pretty neutral pH, which means it was pretty much potable. Like you could drink it if you lived in Mars 4 billion years ago, which I was not. But point is, if there were life, there was probably life, right? So what happened to Spirit? Spirit kind of died earlier than Opportunity, but it still lasted a good chunk of time. In 2010, it got bogged down in sand trap, and then it's solar arrays couldn't get enough sun, so essentially it couldn't heat it up. It froze to death. Opportunity lasted for 8 more years, so it in total it put in 28 miles on its odometer. I'm not sure if it has one. No, it definitely has one. Otherwise, how would they know? 28.06 miles, which was more than any other vehicle that has traveled on another world. So amazing. And unfortunately, in May 2018, there's a storm that came, put a bunch of dust on its solar panels, and then it couldn't boot up, alas. Okay, let's hear what our wonderful NASA guy, Thomas Zurbuchen, has to say.
I was there yesterday, and I was there with the team as these commands went out into the deep sky, and I learned this morning that we had not heard back.
All right.
And our beloved Opportunity remained silent. It is therefore that I'm standing here with a sense of deep appreciation and gratitude that I declare the Opportunity mission as complete, and with it, the Mars Exploration Rover mission as complete. I stand here surrounded by the team, and I have to tell you, this is an emotional time. I stand here surrounded by a team that before I even came to NASA, I got to know as I watched this amazing entry, descent, and landing, the development, and of course at the center of that were 2 people. Pete Theisinger, who is right here ahead of me, is a hero in the world that we live in. And right next to me right here is Steve Squires. You're going to meet him later, another hero for all of us.
All right, so that was Mr. Zurbuchen, the NASA Associate Administrator of Science Mission Directorate. It's a wonderful message there. All right, so they didn't give up right away, They try to continuously ping Opportunity since June 10th, but finally they said, okay, you know what? Guess it's never going to become alive. It's fine. So, all right. Anyways, right. Typically, we're near our first break, but let me jump into the great beyond for a little bit before I take our break. So let me. So interesting thing is we have finally some evidence explaining how the heating of interplanetary space, particularly plasma, works. All right. So this is thanks to actually, first of all, let me explain what's going on. So there is this process known as Landau. Probably I'm saying his name wrong because I can never say any scientist's name right. Landau, damping. Okay, which is responsible for transferring energy from the electromagnetic plasma turbulence in space to electrons in a stellar wind or solar wind for our sun, right? Causing their energization. All right. So basically, a wave travels through plasma, and the plasma particles are traveling at similar speed absorb this energy, leading to a reduction of energy of the wave. So, some of you guys may know already that the most common state of matter in our observable universe, which I mean, not including dark matter, all right, is plasma state, all right? And plasma state is extremely hot temperatures, like in stars, most of plasmas, but also not just in stars, in interstellar space as well. That state, a lot of it's plasma, all right? So, one of the great mysteries, for instance, that scientists are still trying to understand is why the solar corona, you can think of it as outer atmosphere of the sun, is hundreds of times hotter than the surface of the sun, which does not seem intuitive at all. So, this study, this new, what do you call it? Data, there you go, can show that, helps with this. And where's this data from? Well, this is where NASA's spacecrafts really help, right? So this is one example where, space agencies are doing great science. So we basically, the researchers here, they got this data from high-resolution measurements of NASA's magnetospheric multi-scale spacecraft, which was launched in 2015, MMS. Together, they used a fancy new data analysis technique called field particle correlation technique, which, if you ask me what it is, I don't know, since I haven't done that research. And yeah, but anyways, so who are these researchers? Well, the Queen Mary University of London, also with the University of Arizona and University of Iowa. So they published this paper in Nature, and basically in this paper they described the first direct measurement, which came from the spacecraft, of how energy is transformed from these chaotic electromagnetic fields in space to particles that make up the solar wind, which leads to the heating of interplanetary space. Now, I say heating of interplanetary space, but guys, it's still not, that hot, so to speak. I mean, you will still freeze to death, all right? So, mainly because these particles are moving really fast, but there's not that many of them, okay? So, technically, it's still in plasma state, and quote unquote, I guess it has a high temperature, but it doesn't mean that you actually feel it. Okay, that's just an aside, extra information. All right, so this paper also could pave the way for future missions. For instance, the NASA Parker Solar Probe, which launched last year, which is beginning. That's a spacecraft, as I mentioned before in previous episodes, that is the closest, that is going to be the closest spacecraft to ever approach the sun. And the NASA Parker Solar Probe is going to explore the solar corona and plasma environments near the sun. So no doubt that will provide even more, data for which researchers can maybe finally figure out what is going on with the solar corona. So with that, we're going to have to take a short little break. And when we come back, let's talk about galaxies colliding. Yay. Who doesn't love that? All right, SG2 on Space, episode 21.
Action 1, inspiring action.
When the so I challenge you today to start strong.
Start the revolution. When we turn up, we shut it down. We are skywalkers. The spheres of my Kabbalah, illuminated properly in sight, shows the man in universe and the creator's gift of life. When the earth collides with every piece of star from afar, there's a higher probability of
Join today. Get in the action at weareA1.com.
We are back in the studio. You're listening to SG2 on Space, episode 21. This is your host, Shen Ge, S-H-E-N, last name G-E. So, before we went on break, we were talking about heating of interplanetary space. Finally explained, initially explained. There's a lot more research to be done there. And earlier than that, our first topic was about how the Opportunity Mars rover died on February 13th. Confirmed dead, let's just say. It hasn't responded since June last year, but finally JPL scientists decided to throw in the towel. It has had a merry life for the last 8 years, so wonderful. Okay, so what is going on with Andromeda Galaxy here? Well, we all know. You know what? I really shouldn't say we all know, because not everybody knows, right? So, first of all, Andromeda Galaxy and Milky Way Galaxy and this other galaxy called Triangulum Galaxy, M33. Andromeda, by the way, is M31, and Milky Way, as far as I know, is just Milky Way. These three galaxies are the largest galaxies of what's known as the local group. All right? Local group, which is a very tame name, I will say. It's basically the galaxy group, all right? And it has more than 54 galaxies. Most of them are dwarf galaxies, okay? So they're fairly small. Its gravitational center of the local group is somewhere between the Milky Way and Andromeda Galaxy. So, just to give you some extra information, the local group is, think about it as, you know, you live in a neighborhood with your neighbors, right? Your subdivision. That's what our local group is. And your neighbor Andromeda has the biggest house, all right? And everybody decides to congregate somewhere in between your house and Andromeda's house, all right? That's just an analogy. And everybody's, you know, all the other smaller folks gravitates there. Now, the local group itself is part of what's known as as part of the Virgo supercluster, which, as a name, sounds way cooler than local group. And that's a mass concentration of galaxies that has at least 100 different galaxy groups and clusters. All right, and Virgo supercluster in 2014 was discovered. Virgo supercluster is only a lobe of an even greater supercluster called Laniakea. And Laniakea supercluster has approximately 100,000. Anyways, it's ridiculously huge. Point is, even our observable universe is humongous. All right. So, where am I getting with this? Let's go back to Andromeda and Milky Way. Well, astronomers have known for a while that Milky Way and Andromeda is going to collide at some future date, and the best guess for that rendezvous was 3.75 billion years from now. So, you know, our house is going to collide with their house. Okay, maybe that's not good enough. Two cars are going to collide. Okay, how about that? But it's not that bad, alright? So, recent evidence, based on data released from ESA, that's European Space Agency's Gaia mission, has brought some new clarity to this future collision. So what is the Gaia mission doing? The Gaia mission is making a 3D map of our Milky Way galaxy, and it's also doing that for parts of the local group. So now in the future, we'll have a navigation map of our whole Milky Way galaxy. It's wonderful. So, Hubble Space Telescope has given us really sharp views of, you know, stuff in the local group, but they unfortunately don't give us, Hubble doesn't give us stuff like positions and motions of these individual stars, whereas Gaia does, right? So what happened is that these researchers combine the existing data from Hubble and other optical telescopes, or other telescopes don't have to be optical, with new data from Gaia, all right? And using that, they created a more accurate picture of how Andromeda and Triangulum are moving through space. And they projected this into the past and into the future for billions of years. Imagine that, being able to predict the future for billions of years. That's pretty amazing. The wonders of physics. All right, so what they discovered, rather than collision, there's going to be more of a glancing blow. By the way, when galaxies collide with each other, you know, you shouldn't think of it as a disaster. What essentially happens is that most of space is still kind of empty, right? So it pretty much, there's almost no chance that any stars or planets are actually going to collide. So this thing is going to take me about 4.5 billion years, which, is like what? That's about a billion years later than previously anticipated. So, predicted, I should say. So, any case, not that it affects us that much, because I'll be long gone by then, I would think. So, now, how fast is Andromeda heading towards us? Take a guess. It's super fast. It's 110 kilometers per second. So imagine your car can move like 60 miles every second or something. All right, that's pretty ridiculous, right? So, any case, now that was previously though, but with the new data, we found that Andromeda is sliding sideways more quickly at around 50 kilometers a second. So what that means is that the orbit of the two galaxies will be more of a glancing blow than a head-on collision. So, but whatever the case, ultimately we will collide. And by then, Earth will be pretty much uninhabitable, and nobody will be living on Earth. So that's something to worry about in the future. This is just interesting from the science perspective, right? Okay. So, all right, moving on. We're going to take a little different take on things. Since I've been thinking about this topic for a while, and it's not like there's, recent, this is, okay, point is, I figured we'd go into slight philosophical discussion a little bit about what kind of universe do we live in. All right, so, now, what I mean by that is, do you think you're real? I mean, do we live in a simulation? That's the question, right? So I was reading this paper. This original paper was written actually back in 2003 by this guy named Nick Bostrom. He's an Oxford philosopher who, like many of us, dreamer types, tends to think of things like whether we're real or existing or not. I'm sure, some of you guys may have sat on your couch or laid somewhere and be like, am I real or is this just a simulation, right? So what the general crux of that is basically that at the rate technology is advancing today, it's likely that future generations will have access to supercomputers beyond our imagining, right? And since we tend to use computers, right now at least, to run relatively primitive simulations with our current technology, our future humans or another advanced alien species will likely to do the same, perhaps simulating their ancestors. That's right, you might be a simulation of some future human race simulating their ancestors. That's pretty crazy. Wow. Huh. Wow. Alright, so and with all this extra processing power, right, it follows it would probably run a lot of simulations simultaneously. So, in other words, the number of artificial universes would vastly outnumber the one quote-unquote real universe. So statistically, it's much more likely that we live in one of those simulations. So, now, astrophysicist Neil deGrasse Tyson has put us with the odds, living in a simulation of 50-50. Elon Musk has said the chances like 1 in a billion that we inhabit the one true world. Oh, what a pessimist he is. Which is funny because he wants to go to Mars and all that, but then we're like, you're going to a simulated Mars. What's the point? All right, but anyways, that conversation aside, that's interesting, right? So how would you resolve that? I mean, can you even tell? This seems like an irresolvable problem. Like, come on, if we're simulated, then how are we to know we're simulated? Well, these guys, Zohar Ringel and some other physicists from Oxford and Hebrew University has looked into this and consider it that we're very unlikely to be in simulation. And the reason is due to a quantum phenomenon known as thermal Hall conductance. All right. So, also known as a type of gravitational anomaly. All right. So, these anomalies have been known to exist for decades, but are really difficult to detect. So, they arise in physical systems where magnetic fields generate energy currents that cut across temperature gradients. So, basically, temperature changes, right? So, basically you have magnetic fields that create like charged electrons, say, like electrons that are charged. That basically say cause electrons to move, or and then the electrons cross from high temperature to low temperature, or vice versa. All right. Typically, this is especially observed for very low temperatures. All right. So, what we have done is what these guys have done is that they found that quantum systems that contain these gravitational anomalies are extremely complex, and they think it can't be simulated. So when they did the calculations, they discovered that the quantities involved in the simulation will acquire a negative sign. So essentially, there's an infinite number of possibilities. So the simulation can't possibly consider them all. So putting it further, what this also means is that as the simulated system gets more complex, the computational resources required to run it needs to advance at the same rate. And that rate might be linear, meaning that every time the number of particles simulated is doubled, the required resources is also going to double. Or it could be exponential, which means that the resources have to double every time a single new particle is added to the system, right? So what does this mean? This means that simulating just a few hundred electrons that's undergoing this gravitational anomaly would require a computer with a memory made of more atoms than the universe can contain. Now, considering our universe contains 10 to the 80th particles, that's 10 followed by 80 zeros, which is ridiculously huge. The number of atoms that's needed to simulate that many particles is pretty much incomprehensible, and you can't solve it. All right. So, basically, this guy, Zohar Rangel, co-author of the paper, says, our work provides an intriguing link between two seemingly unrelated topics, gravitational anomalies and computational complexity. It also shows that the thermal Hall conductance is a genuine quantum effect for which no local classical analog exists. All right, wonderful, right? So, nope. You know what I think? I think they've only considered using classical computers. But what if they use quantum computers? They need to think about that. So, from what I think, we could still be in a simulation. Because no doubt any advanced society would not use classical computers. They would use quantum computers, which will be able to compute like millions or billions at the same time, so to speak, computations. And for me to explain that would take forever, and I would need to review quantum physics, so let's skip that. All right? So, but it is really interesting. And I'll share this paper and see what you guys think. Okay. All right. We have hit the halfway mark, which basically means we have to hop on the horse, for Space Cowboys. Right? Yes. There should be a sound effect to this, but there never is. I wonder why. So, but moving on. All right, little snippet here. Do you want to move to Mars? Guess what? Round trip ticket will only cost $100,000. This, of course, is according to a optimist called Elon Musk, who recently tweeted this, and it got skepticism as well as people wondering how, right? So, what did he happen that the qualifier price is so basically it means you got a whole bunch of people on Mars and back, and then the price is lower. Of course that makes sense, right? It's just like airplanes. Imagine you buying one ticket to fly one plane. That's much more expensive than 500 people or 300 people, sitting on one plane, right? Kind of distributes the cost. And if you do that very frequently, you can charge less and you have more customers, so to speak, if you think about it that way. But when is it going to go down to this level? I don't think it's going to go down to $100,000 per person anytime soon. So, but it is in the future, perhaps. Maybe you can take a vacation on Mars. But still, $100,000 is still a lot. All right. Maybe some rich people can get. In any case, moving on from that Elon Musk tweet, let's talk about the small satellite company named Fleet Space Technologies. And the reason I mention them is because we don't hear about that many companies based for new space companies, right? That's outside of the U.S., right? So, I mean, outside of the U.S. or Europe for that matter. But Fleet Space Technologies is one of them. So, what is and the further thing interesting is that they are doing something called the Internet of Things. Now, no doubt, many of you have heard of something called the Internet of Things. Just to note, they're an Australian company. All right. Considering that the Australian Space Agency didn't even exist 5 years ago, now they have all these space companies coming out. That's wonderful. All right. So, basically, Internet of Things. What is that? Well, Internet of Things is how network devices, pretty much including, say, your cars, home appliances, basically everything, that can connect, interact, and exchange data. So it's intelligent systems crossing all sorts of devices, sharing common software, right? So, now, one common example of this, for instance, is a smart home, right? So IoT devices are part of like home automation. So part of lighting, heating, air conditioning, media, security systems. So essentially, say you're not there, lights could turn off, security can do its own thing, and everything can communicate with each other, all right? So Fleet Technology is trying to expand that into space. So it's quite remarkable that it has registered 1 million devices in less than 24 hours. So imagine that. Imagine like 1 million devices signing up to use Fleet Space Technologies satellites. That's pretty remarkable within 1 day. All right, and considering the fact that they haven't even launched all their satellites, that's pretty amazing. So Flavia Tata Nardini, so the CEO of this South Australian company, Fleet Space Technologies, said that the company's Project Galaxy is going to connect devices for $2 per year. This is in early February 2019, right? Well, this month, which is pretty amazing. $2 per year or less, right? So, any case, that is quite remarkable. So what do they have right now? Well, they launched the first of their nano satellites in 2018 on board SpaceX, Rocket Lab, and Israel. They actually launched, I guess, 3 times. All right. So, but now they're looking to launch additional 10 satellites by the beginning of 2020 to meet the demand. So they're going to join 50 million LRA devices. LoRa, by the way, I did not know this prior to. Alright, so LoRa, what does it stand for? No idea what it stands for. But LoRa is basically a particular kind of wireless radio frequency technology, alright? So there's a lot of, it has become the de facto technology for the Internet of Things networks worldwide. So if you're going to go into Internet of Things, you're going to work with LoRa, L-O-R-A based devices. Alright, so it's going to join 50 million of those devices online as of 2018 across 100 countries, right? And in the future, obviously, that's going to increase even more, the number of devices that communicate via, that are LoRa based. Alright. So, that's going to be remarkable. So whether just one of their customers, by the way, are going to have 8 million sensors to connect in the coming year. That's pretty darn amazing. They have raised $3.8 million so far, and they're looking obviously for more money so they can launch the rest of them, or launch 10 more satellites. So let's see what happens. This is pretty amazing stuff here. All right, so speaking of launching satellites, okay, so like I said, they use SpaceX and Rocket Lab's Electron rocket, as well as the ISRO, Indian Space Research Organization's PSLV's Polar Solar Launch Vehicle. We've all talked about these before, but there's another company which I found interesting recently, which changed its name. It's called ExoLaunch. So previously they were called ECM Space. So now they're called ExoLaunch, EXOLAUNCH, and they are, I guess, upgrading their launch vehicle. In 74 days, their new website will open. So I buy new specs or something. So that's at exolaunch.com, exolaunch.com. So this spring or summer, they plan to send 40 small satellites, including 16 CubeSats, for this in-space transportation startup, Momentus, into orbit. All right. So, yep. So, and isn't it wonderful that? Well, I don't know if I should call it Exolaunch a startup. Maybe I would call it a startup. So it's doing that. All right. So Exolaunch was a spin-off of the Technical University of Berlin, and so far has helped 54 satellites into orbit. A lot of these were German spacecraft funded by German space agency DLR. But of course, they're always trying to expand the market. So, in any case, just a note here though, they are not exactly doing their own launch vehicles. They kind of help coordinate. So they match small satellites with suitable launch vehicles. But interesting thing here is, which is what I think their new website will show, is that they are designing their own deployers and separation systems to allow deployment of CubeSats and microsatellites in 15 to 150 kilogram range. So that should be interesting. Okay. All right, and just a note here that very interesting Momentus startup. So they are also doing something quite interesting. They are offering the equivalent, as they put it, a connecting flight, right? So, you fly on airport, not fly on airport. You fly on an airplane now. You land somewhere, and then you have to connect to somewhere else, right? Because you're not at your final destination. So, what they have here is that typically these larger rockets, they're not going to be able to deliver your particular satellite if you're not the prime satellite, right? If you're not the biggest satellite in there, they're not going to deliver you probably to your desired orbit. So Momentus Space helps that by giving you a ride, so to speak. So you can use a big rocket to fly to common orbit on a cheap ride share. Then you can use the Momentus Space water-based rocket to get to any customer orbit. So supposedly they're fairly cheap. I'm going to have to look into the technology and see the pricing before confirming that. So, all right. So, okay. Let us see here. Okay, we're going to talk about the moon because everybody wants to go to the moon. All right. So, I keep talking about the Chinese agency, China 4, blah, blah, stuff like that, right? We are going to have to take a short little break in a few minutes, so I will talk a little bit faster. Point is, European Space Agency also wants to build moon bases, and they have teamed up with the universities, including the National Technical University of Athens, where they apparently took part in this thing. A bunch of young researchers took part in this thing called Spaceship EAC, ESA initiative, who works on these really interesting ideas. So let's watch a short little clip about this, what European Space Agency, what these guys have in mind for a sustainable lunar habitat. So, and habitat, I mean, you're going to live there, right? You're not just going to go there and come back like what we have done with Apollo. So, these things are going to be inflatable, prefabricated structures. It's going to have its own life support system. All right, and there's all these cool designs. There's going to be EVA equipment, extravehicular activity equipment. And it's going to be in this crater, protected from radiation and micrometeor impacts, hopefully.
In cooperation to realize a moon village, an international community of explorers realizing this generation's ambition of lunar exploration. We present here our architectural and mission concept for the initial stages of the moon village. Our proposed location, the South Polar region. Here we benefit from steady illumination, ready communication with Earth, and proximity to a number of valuable resources, such as 3 water-rich craters within just a few kilometers. The lunar habitat will be built inside a crater and buried in regolith. Construction starts with the first module, placed on the crater bottom. After inflation, the life support systems are attached, and the crater is partially filled with regolith. The next modules are sealed to the previous ones, inflated, and again covered in lunar dust. Embedding the structure in regolith shields the astronauts from harmful solar and cosmic radiation, and provides thermal insulation, protecting the astronauts from the extreme temperatures found on the moon. As a last step, the airlock is put in place, and a final layer of regolith protects the surface elements from the hazardous environment. Inside the airlock, we achieve dust mitigation using the electromagnetic properties of lunar dust and store EVA-related equipment. The connection between floors is provided with a lift mechanism inside a central tube. In the first module, we find the EVA preparation and service operations, along with the waste treatment facilities. The middle module is reserved for research and communication efforts, providing the 4 astronauts with a reliable connection to home.
Alright guys, we're gonna have to cut this a little bit short. We need to go on commercial break. And once we're back, we will talk about astrobiology, or all I really want to talk about is super weird alien stuff. And dimensions. Interdimensions.
There's a formula. If you follow the formula, you will be successful.
Facts.
You will make it. Like, there's no way that you won't. So I was like, I'm gonna listen to all the advice that I can, figure out what this formula is, and then follow it. Now I'm like interested in learning how to code, and I'm realizing that that program that she did is probably similar to what I would need. So the plan was to spend a few months saving and studying, 3 months of school, 3 months of job hunting, and all of that together put me at a year. Hearing the stories of people who've done exactly what I'm trying to do was very reinforcing. It's not trying to make it to the NBA.
Put your money where your community is. Get in the action. Action 1. Independent thinkers working together. Inspiring action in media. Get in the action. Inspire today. Join us by being a sponsor at weareA1.com.
Holding on so we can make it last. 'Cause we got that fire in our bones, taking off on the road. Here we go, oh, here we go. We got that fire in our soul, little out of control. Here we go, oh, here we go.
Alright, glad you guys can hear me now. You've been listening, and you are still listening to Shenge, S-H-E-N-G-E, SG2 on Space, episode 21, the only weekly space show in Houston and Texas, unless somebody corrects me. So, and I don't think anybody will correct me. We talked about what? Mars rover, Opportunity, finally dead. Boo-hoo. Okay, that was not sarcastic. That was just boo-hoo. Heating of interplanetary space, thanks to magnetospheric multi-scale large-scale spacecraft NASA's collision with Andromeda shifted back about a billion years and is glancing collision not head-on. Good job. Something Elon Musk tweet that doesn't sound reasonable. Fleet space technologies, the Internet of Things, which is the future. I'm glad there's some Australian company is doing that. Small satellites combined with Internet of Things. Great idea, guys. Exolaunch, a new space company, German company that's doing some cool stuff and launching some really interesting satellites. And then European Space Agency's futuristic moon initiative collaborating with various universities in Europe. So, NASA, thankfully, also has a longer-term vision than just in our particular solar system. As you know, there's been a lot of exoplanet discoveries, right? And this is something I keep going to because I really want to find life or presence of intelligent life, especially in space. So I'm glad that NASA has partnered with universities to do an initiative called Network for Life Detection, which essentially combines NASA centers dedicated to astrobiology with academic scientists. So, so far, there are 3 different groups, all right? So, Tori Holler, a biochemist at NASA's Ames Research Center, will lead the new astrobiology center there at NASA Ames. All right. Then there is one that is focused on biosignatures, the fingerprints of life, that could be visible from a distance. And then there's the third center called Oceans Across Space and Time, which focuses on current and former ocean worlds like ancient Mars and icy moons of our outer solar system. So, and then NASA plans to bring in more groups over the next couple years to do this research, which is profoundly interesting, I would say. Very profoundly interesting. So yeah, let's see what happens here. I can't wait for them to at least discover something, guys, right? All right, speaking of discovering something, I'm pretty sure that aside from being visited by aliens, and aliens already here, and alien spacecrafts flying in there, up in the air, and Bigfoot walking around here on Earth, which I have all discussed about, pretty sure we're also going through dimensions, and some people are doing it subconsciously. And I'm not talking about time travel here, I'm talking about other parallel universes, right? I figured I would jump into this. So, for instance, let's take this story, which, as always, you guys can think this is true or not, it's up to you. But supposedly in 2006, this woman named Carol Chase McKinley was driving from Paris, California, back to her home in San Bernardino, California. And she decided to stop in her hometown, Riverside, right? That doesn't, it's like, okay, whatever. Then it was like, hey, wait a minute, this isn't my town. I don't recognize any of the houses. This is what she was thinking. But all the numbers are correct. But the cemetery where her grandparents were buried, it was just a fence lot full of overgrown weeds. And then she thought, maybe she's in the wrong town. But then she saw some familiar landmarks like colleges and middle schools, right? So she was like, phew, maybe I'm just drunk or something. Something's up, right? Maybe she didn't say she was drunk. The point is, she saw some like weird vibe from the residents of Riverside who were walking around. And she was like, I'm gonna leave because these guys seem really creepy. Alright. So, and then once she left, she never, she went back to Riverside and she never went to that alternative dimension. So, Carol believes that she went into a parallel dimension. Alright, what do I think? I think she may have, unless she's making everything up. We can never tell because, she's never brought back any proof from that dimension. Alright, even weirder. Dimensional hop in the desert, that's what I call it. So in May 1972, and this one we do have proof. Alright, sort of, unless you believe it. Don't believe it. 4 girls were driving back to Southern Utah University, right? They spent their Saturday at rodeo in Pioche. Okay, so while driving the desolate desert, Utah-Nevada state line around 10 p.m., they came on the fork in the highway, so they decided to veer left and drive through Gadianton Canyon. Why not? That's a shortcut. Alright, suddenly the black cement turned to white cement, and they were like, what the heck is going on? So they decided to head back the way they came. But when they went back, they were no longer in the desert. They saw grain fields and ponderosa pines with no desert. So they decided to stop at a roadside tavern to ask for directions. But before they could even get out of the car, one of the girls started screaming hysterically because they saw these 4 egg-shaped vehicles mounted on tricycle wheels. Yeah, I'm not making this up. With bright lights shining from the top of them, speeding after them. Alright? And they were like, holy, insert whatever you were there. So they went back in their cars. I'm not sure if they even got out. So they drove back in the canyon, and they drove past the white cement, and they ended up on black asphalt, and they're like, oh, we're back in the desert again. And they were so freaked out, they wrecked their car in Creek, because that's what happens when you go to a parallel dimension that you do not want to happen. Alright, they wrecked themselves in a creek, and they have 3 flat tires, and they can't go anywhere, so they wait until morning to hike to Highway 56, where they flag down a state trooper who doesn't believe anything they say. Alright, so you might think, oh my gosh, these girls, they just got drunk and like totaled their car or something. They want to tell their parents or whatnot, right? Well, as outlandish as their story seems, the tire tracks they left are really hard to explain. The only tire tracks left by the girl's Chevy ended abruptly only 600 feet into the desert. Where did it go? Suddenly disappeared. And then how the heck did the girls end up over 2 miles north of the highway with no physical evidence of their travels? And the car was also missing a hubcap that was never found. So maybe it's in the Utah desert, or maybe it's been displayed at some museum in that parallel Earth, where apparently people drive egg-shaped vehicles mounted on tricycle wheels. Alright, who knows? Maybe that's their police. I don't know. I mean, come on. So, gosh, if I was them, I would have stayed there and checked it out. It's like, wouldn't it have that been interesting? But beside people visiting other universes and then coming back, thankfully, I'm going to give you one last case before our show is over for the day, but this one freaks the heck out of me because I never hoped to be in this scenario. So there's this lady, right? So Lorena Garcia, and you can read her full account on this webpage. So in July 2008, so she's 41 years old. She woke up in her bed on what seems like an ordinary day. However, when she went on her normal routine, she found small details that was weird. For instance, her sheets and pajamas were different from what she remembered wearing to bed. She went to work, where she had been employed for 20 years. However, upon arriving at her department, she realized that actually wasn't her department of work, even though it was the same location, the same floor. And she's like, something really weird is going on. So she went back home, and she found her former boyfriend, who she had separated 6 months before, and that guy acted like they had never split up, which kind of sucks, alright? And apparently her new boyfriend, whom she had claimed she'd seen for 4 months, was nowhere to be found. And she hired a private detective, and they never could find him. So there was no trace of him at his residence, nor any trace of his family. And, there's more details, but basically, Garcia has never been able to return back to her normal universe, So she's basically stuck in a dimension where she really doesn't belong with a boyfriend she hasn't been able to get rid of. That sounds horrible. So, let's hope you don't wake up one day and be like, oh my gosh, I have not been abducted by aliens, but I am stuck in a parallel dimension where my significant other doesn't exist and my job doesn't exist. It's like, what the heck? That sounds really bad, alright? And then you try to tell people and most of them think you're crazy. Unfortunately, that's what happens, right? So, I figured if a whole city disappeared, like in one of those sci-fi movies, and went to some other parallel universe or something, and then our city here got replaced by their city, kind of swapped places, then, people with these experiences would not be so easily dismissed. I myself think some of this is true. I mean, there's just so many of them. Why would people make up this stuff? Okay, some of them might, but others? Why would you? It just adds more hassle to your life. I mean, you could say she's neurotic, but how do you just wake up one morning and decide to be crazy. I mean, and that particular kind of crazy too. That's just wild. So I think, yeah, sorry, whatever name is, Lorena, you're stuck in our universe. So good luck. All right, with that, typically I tell you guys to look up, and I still would. But add on to that is when you wake up in the morning, check your clothes, make sure you're wearing the same thing as before, and check that your significant other is still the same person. All right, that's if you have one. Yeah, that's what I would do tomorrow morning. Actually, I put a note on that. Every day, gotta remember it. All right. Actually, don't drive yourself crazy. Don't do that. Just look up. All right. Aliens are probably much more likely than these weird stuff. So, with that aside, you've been listening to SG2 on Space, episode 21. This has been pretty darn fun, and as always, we'll be back next week, same time. I guess you don't care about the same place, but I will be at the same place. So, be sure to follow us at facebook.com/action1media. Also, go to the website at weareA1 with the number 1.com. Follow me at facebook.com/theshenshow, THESHENSHOW. Of course, we also have a YouTube channel right now, which is, you can look up Action One Media, and all my shows should be there. And feel free to support me at patreon.com/SG2. And if you wish to sponsor the show, you can also contact Action One Media or me, Shen. Just send me a message on Facebook, and I'll be happy to do so, to talk more about it. All right, take care, everybody. This has been episode 21 of SG2 on Space. Ciao for now, and look up. Never know what you will see.
Put your money where your community is. Get in the action. Action One. Independent thinkers working together. Inspiring action in media. Get in the action. Inspire today. Join us by being a sponsor at weareA1.com.
Peace, it's Brother Atum Ra, and you tuned in to Action One Network.